Okay, problem, this is 1035. It wants you to solve this equation here for real numbers, all right? So I want to go to Sage and type in Sage, of course, to launch it, installed on my machine. You can also use this online if you want. And I'm going to type in the equation. I'm going to type in EQ. I'm going to type in a function instead. So let me just reset and define a variable x. Whoops. And then define a function f of x. And that function is going to be x to the 12 plus x to the 8. That's the top of the problem, and the bottom is x to the 11 plus x to the 9. All right? They're going to see if if Sage can solve this equation. This is when f of x, the double equal sign is indicating that it's an equation, and the equation here is that f of x, when is it equal to 5/4? And we're trying to solve for x. Of course, it gives me answers, and it's giving me the same answers I got over here that we went through the work. I just want to, scroll through that. I'm not going to certainly read that, but you could. You could write that down and read it. But I'm going to say that Sage has the ability to solve that equation. Now, how did it do that? I'm not really not sure. I guess I could look at the source code and figure out what they did, but that would be a big effort for me. Now, of course, when I went through it, I'm not saying this is what Sage did, but this is what I did. And, looking back over it, I noticed that it really wasn't necessary to do this particular U substitution. I could use a different one to get the solution problem, but that was not the issue. The issue was getting the x in the problem, which to me took some paper and pencil work to figure it out. And I was able to get these solutions over here. All right. Now I want to go back to Sage, and I want to talk about why I did this code over here. So let me go back to Sage. I'm going to clear the screen, and what I did was I wanted to check my answers over here. I want to check to see if they're right. All right. And the way we did that, let me reset again, was I actually typed these numbers in, one after another. Now, the first one I put in was, I think I put this one in, then this one, then I put the complex ones in. What I'm going to do, though, is I'm going to go to the source code for this and just copy this in. I don't want to retype it or copy it from the document. Let me go back to Sage and do that. All right. Now, if someone says, I wonder what x1 is, I could type x1, hit return. It's that there. If I wanted an approximate to that, I would use the underscore. Right? I'm going to do x1, and then I'm going to do dot, and I'm going to use that end notation. And I get that there. Let me do x2, approximation. Oh, you know what? I made a mistake there in copy. Sorry about that. All right, that's not so bad. And then let's do x3. Dot n. Get that number there. And let's do x4. Dot n. I'm getting those approximate answers there. Now, they were looking for the real solutions. I want to claim that what I did over here, I just pull up the Sage again. I did put the approximate down. So how'd you get the approximate? I actually used Sage to do it. So I got this approximate over here, and I got this approximate over here. But that's the numbers I found. The question is it right? All right. So let me go back, and I'm going to define x to variable now. I'm going to type in the f of x. We did this before, so I got it in my memory. And then I'm going to ask Sage, is it really true? Those numbers that I came up with, is it really true? Boolean. And then it's going to be f. I want to see if x1, is that identical to what they said it was, which is 5/4. Now, this is either going to be true or false, but Sage sometimes has a hard time with the arithmetic. It has no trouble. It says it's true. Now, let's try x2. Yep, true. Let's try x3. Let's try x4. All true. All right. So our work led to correct answers. 2 complex, 2 real. Were we expecting that? Well, yes, and I'll tell you why. The x to the 8th is it's clearly it cancels off because x is clearly not equal to 0, because that makes no sense at all, because the bottom would be 0. And then you have a 4th degree polynomial, And my suspicion about the way Sage did this was they actually got a fourth degree polynomial and they used some tricks to factoring it and come up to solutions over there. Again, I thought it was not too bad to get to this business over here. What I felt was difficult was actually solving for x in the end because it was kind of a nightmarish numerical problem for me. But again, I went through that. I didn't check my Sage work over here, the Sage answers, but I'm pretty sure they're the same answers we got over here. Same ones. Thank you.